Welcome back. This is section 10.3, which is centripetal force, and section 9.3 in your textbook. Centripetal force is a force towards the center of a moving object in a circle. So if you've got a rope attached to a ball and you're slinging the ball around and around and around, the ball is being held in a circle by the tension in the string. It's acting towards the inside. Now, when you go around the outside of a curve, if you're in a car and you go on the outside of a curve, it feels like your body wants to be slung to the outside, but there's no force acting towards the outside. The force is actually acting towards the inside, and what keeps your car in the path is actually the friction of the tires on the road, and the force is acting towards the inside of the circle. So the force of that object is dependent on a few things. It's dependent on the mass of the object, how massive it is, how fast it's going, its tangential speed or its linear speed straight ahead, and how far away from the center it is. Now, if you've ever started to learn to drive, one of the first things that's scary about driving is going around a curve. If you are going the speed limit, let's say you're even going lower than the speed limit, and you go around a curve, you feel an acceleration, even if you don't go any faster. If you say the speed limit is 55 miles an hour, and you start around a curve where there's a radius around a mountain or something, then what's going to happen is you are going to feel the acceleration. You're not getting faster. Your engine is not getting faster, but you are accelerating. The acceleration is what makes you feel like your head wants to go to the side. That is called a centripetal acceleration. So there's two things that will accelerate in a car. Three things. You can have the gas pedal. The gas pedal will accelerate, make you go faster. The brake pedal will change your acceleration to make you go slower. So that's a negative acceleration. And the steering wheel can accelerate you if you turn the steering wheel. If you turn the steering wheel and you start moving the car in a circle, then you will have an acceleration towards the center of the circle. Now let's look at why. If you remember that velocity was a vector quantity, okay, and it was a distance over a time. And now I want to know what acceleration is. Acceleration is a velocity over a time. Well, there's two ways I can change the velocity, or three ways I can change the velocity. I can make the speed of that velocity go up, and that's a higher speed. I can make the speed go down, so I'm accelerating it by making the speed go up. I'm accelerating by making the speed go down, a negative acceleration. Or, since vector is a direction, if I change the direction, then I have a change in velocity over a time, and I've accelerated. And that doesn't necessarily seem logical. It seems like you should be able to get faster to accelerate. But if you change the velocity at all, you've accelerated. So if you turn the wheel in a circle, you are going to get an acceleration, and that's called centripetal acceleration. Okay, and it's heading towards the center of the circle. The acceleration is always towards the center. The force directed towards the center, remember, if you have a rope with a ball and the rope has a tension in it, making it go towards the middle, then the ball, instead of going straight ahead, is forced to travel in a circular path. That is called the centripetal force. This is the centripetal force, and it's the force towards the center that's making the object, instead of going in a straight line the way it wants to go, remember Newton's first law, it wants to go in a straight line and unimpeded, except acted upon by another force. Here's the other force. If you have a centripetal acceleration, it forces the ball out of the straight line path and into a circular path. Again, the can seems to want to go this way, but actually the force is acting towards this side, because the can, without this force, without the centripetal force, the can would go in a straight line in whatever direction it happens to go with the second. If you were to let go of the string, the can would not travel in a circle anymore. It would travel in a straight line because objects always travel in a straight line with whatever velocity that they've got. So it's the force that's forcing it into a circle. This apparent force, the apparent force that makes it want to sling to the outside, you feel like there must be a force if it wants to pull to the outside, is only the fact that it has inertia. And inertia doesn't want to change its motion. So it doesn't want to change its motion, but yet the force on the inside is making it turn in a circle, and it's always wanting to stay in the same space. So let's do a circle from the top. If it wants to go this way, but the string or the force makes it go here, do you see that from here to here, it makes it appear that it's wanting to sling to the outside, because no matter where that is, here's the straight line force, and if it moves in a circle, it's wanting to go to the outside. So that is not a force. There's no external force on it, only the internal force called centripetal force. The apparent force has a name. It's not a force. It's called centrifugal, like a centrifuge, centrifugal force, and it's not a force. So it's actually just the apparent of why it wants to go to the outside. Why does your head want to go to the left when you turn a circle to the right? Now, these forces can be caused by different things. If you have the tension on a string, if you're slinging a can or a ball on a string, then the string is pulling in, but the Earth goes in a circle around the sun. The sun goes in a circle around the center of the galaxy. So what causes that? Where's the force inward towards the sun that's making the Earth not go in a straight line, but actually turn in a large ellipse as it goes around? Well, that's gravity. So the gravitational force is acting just like the tension on the string that's attached to the ball. So it's forcing it to go in a circle where it would otherwise go in a straight line. So here's a picture of the car that I mentioned a moment ago going around a curve. If the car is going around a curve, it's moving in a circular path. The only reason it would move in a circular path is, instead of a straight line, is that you've got a force acting towards the center called centripetal force. The centripetal force on the car is the friction of the tires on the road surface, and the way that the axle is bent, where you have the axle on the inside facing the back of the car, and the axle of the front right tire facing the outside front of the car, and you end up with the friction of the tires holding on. If you were to have an ice on a curve, you'll go over the curve and go out onto the outside of the circle. That is because there's no friction there, and so the friction is what's causing the force, and it's bringing it in. You want to go towards the outside because that car wants to go in a continuous straight line. So the centrifugal force, which, remember, that is that apparent force, is the fact that if you are here, you feel like you want to go here because you are sluggy, you're lazy in terms of not wanting to move because you have inertia. Any mass wants to continue in a straight line force according to Newton's first law, but since there is a secondary force making you move in a circle, it makes you feel that you want to stay where you used to be, and that staying is towards the right of the circle that you are going left, or towards the left of the circle if you're going right. Cool example. This is what causes the spin cycle in your washing machine to work. If you spin, the water is going to want to remain where it is. It doesn't want to turn in a circle. And so the water, as it's wanting to stay still, since there's holes in that drum, the water can sling to the outside and go away from the clothes. And that's what essentially pulls all the water out of the clothes. It's the inertia of that water while the clothes are being forced to spin because it's part of a constant drum and the water is free to move. Okay, you knew there was math. There has to be math. So everything is described in mathematics. So the centripetal force, which is a force sub C, centripetal, is going to be your mass times your velocity. Remember, we saw 1/2 mass times the velocity in kinetic energy. So this is a motion type thing, divided by r. So The bigger the r is, okay, the bigger the r is, what's going to happen? This number gets smaller and the centripetal force gets smaller. So the smaller that the r is, the closer towards the center that r is, the bigger the force. So if you've ever seen an ice skater skate and they start spinning in a turn and they bring their arms closer in, well, what's happening is their center of mass is now closer to the inside of their body, and they start spinning faster. And that's where the dramatic conclusion to a show is, or whatever, where you're starting going slower, faster, and then you stop. It's because the smaller the speed, because if you were to have F sub c and r together, these are on the same side of the equal sign. As r goes down, the force goes up. So as the radius gets smaller, the force on it gets smaller, or gets larger. You can see that it doesn't have to move in a circle directly out from the circle. It can sweep a circle at an angle. If you've ever seen a little airplane, battery airplane that's tied to a string and attached to your ceiling, like a flying pig. I've seen a flying pig like this, where it'll go round and round and round in circles. What's happening, it's almost like this is the center of the circle, but there's two forces. You've got the mass times gravity, which is the force of newtons of weight of the airplane, and then you have the tension in the line. So this is just another form of centripetal force where you have a little bit more, it's three-dimensional rather than two. If you were to break this down, you're going to see that the component of this tension in the string can be broken apart into a straight up and down force and a straight inside and outside force. Well, this T sub y is going to be the same as the weight. It will counterbalance the weight. So that really the only net force on the object, why it's going in a circle, is this T sub x, which is your centripetal force. So this is your force centripetal, because Ty is going to be the same, opposite and equal as the weight, and then the rest is going to be acting towards the center. That, of course, is going to be equal to what we just learned, mv squared over r. So as I know what r is, I can actually know what the force that's pulling it towards the inside is. Here's a NASCAR track. A NASCAR track always has a pitch in it. It always has it's banked. It's called a banked curve. What's happening with the banked curve? Well, you're going to have a weight. That car has a weight, okay? You're also going to have a centripetal force that's causing it to go around the curve, and that's your N to X. Your N is going to be the support force from the road. Remember, the road is going to have a support force holding that car up that's always at a 90-degree angle to the car. And that support force can be broken into an X component and a Y component. So you can see this is just like the flying pig. You're going to have the N sub Y, which is exactly opposite and equal to the weight. That's going to counter out the weight. And then, of course, this is being broken apart into two parts. The only thing that's left is the N sub X. So that's the centripetal force, which is causing it to go around the curve. Otherwise, it would slide off the curve and crash. So did you learn anything? What factors affect the centripetal force acting on an object? Well, the centripetal force, your F sub c, is based upon the mass of the object, the tangential speed of the object, and the radius of the object from the center of whatever curve that it's traveling on.